Hey guys, Travis here from Hammond Engineering. Going to do a little video today about making a part for a mate of mine, Mark Boxer over at Hoon TV. He's got a massive YouTube channel, does lots of cool car and bike stuff. He's given me this part when I went to visit him a couple of weeks ago. A brake bracket off a CBR900. He's building a superbike replica. So this is a stock brake bracket. He wants to fit this pretty Brembo caliper. So what I'm going to do is measure it up on the CMM and then draw it up and turn it into something that'll actually fit that Brembo caliper.
The tool I'm using here is a Simcore Stinger 2 CMM arm. It's a fairly accurate and quick way of reverse engineering parts. It uses a manually operated probe to measure and draw different parts of geometry. It'll hold about 0.5mm accuracy when you're just using it quickly, and if you take a little bit more care, it can hold 0.1 or lower. Normally what I do with this is just pick up the important dimensions and then go over to my main computer and jump into Fusion 360 and use verniers and micrometers where necessary to pick up any other dimensions. Occasionally I'll jump back over on the CMM to pick up some other dimensions that I didn't get the first time around. A lot of things are easier to measure on the CMM than they are with simple measuring tools. Seeing as Mark's using a off-the-shelf Brembo caliper, I'm just doing a bit of a search around on the internet to try and find a 3D model that someone's already done. Didn't have much joy there, so I've jumped back over onto the CMM to measure up the caliper so that I can get some accurate dimensions to then put that into the model as well. While I was measuring that, it actually moved a little bit, so I've started again and bolting it down a little bit better so that it doesn't move while I'm measuring it, because obviously if your part moves while you're halfway through measuring, you're not going to end up with an accurate result. So what I've achieved here is I've basically redrawn the stock part, and now I'll place the caliper where it needs to be, just checking some reference pictures there, and then start modelling the new bracket. Once I've finished modelling up the part, I'll go into the manufacturing workspace, find about the size of material I need, and then went over to the shelf, found something that I had sitting there, and then I'll just chop a little bit off it to make it so I don't have to machine too much away from it. Now that I have my cut piece of material, I can actually put that in the manufacturing workspace and start programming some toolpaths. There's nothing terribly complicated about programming this part, so I've just gone with an adaptive toolpath to get rid of most of the material, and then I'll finish all of the surfaces and the holes and everything from one side, completely finish one side, including the outside profile. And then I'll cut some soft jaws, flip it upside down, hold it from the finished surfaces, and then just finish the other side in a second op. Here you can see me designing the soft jaws. They're a little bit complicated for this part because of the angle of the bottom surface. So I've had to go in and just chop away a big section so it wasn't trying to sit against that angled surface. For the second operation, I can basically just copy the first operation and change some selected parts because it's basically the same on the bottom as it is the top, just the opposite. Once the programming's all done and I stop getting annoyed by mates, we jump over onto the machine and start getting it happening. So the first process is to probe in the material so that the machine knows where it is. The Renishaw probing system makes that really easy. And then it starts cutting. after it's finished profiling the surfaces, it's going to drill the holes with a carbide through coolant drill. So I've slowed that down to real-time speed so you can see how ridiculously fast they are. Just go through and chamfer all of the edges, make sure it's nice and clean so I don't have to do any deburring once it comes off the machine. And that's the first operation all done. Looking good so far. Flipped over into the soft jaws. I didn't record machining the soft jaws because that's not really that interesting. But here it is sitting in there, and it'll first machine off all of that leftover material from the stock, and then it'll start cutting away at the part. I could do all of this stock removal with a face mill or something like that, but it's a little bit more aggressive, and sometimes when you're not holding things perfectly just in some soft jaws, you need to be a little bit more gentle. That's the second op all done. Time to give it a blow off, pull it out of the machine, and give it a bit of a test assembly with what I have. Alright, got it mostly done. Small clearance problem from the brake pad, which I did not measure at all and just assumed it would fit sort of within the part. So little mod to the part and we will be mint. Another good thing about soft jaws is that you can throw the part back in if you need to, and it'll still be in relatively the same location. So that allowed me to put it back in and machine these little clearance bits that we needed for the brake pad to not touch. And there we have it, all test assembled with the parts that I have. I sent it off to Boxer, he fitted it up. There were still a couple of small issues, which you can see if you go jump over on his YouTube channel. We'll make a few changes for when we do a production run, because there's quite a few people that are interested in getting these parts. If you are interested, hit up Boxer, because he's going to organise the whole thing, and I'll be making them. I hope you've enjoyed this slightly different format of video with a bit more information. Like, subscribe, do all those cool things, and I'll catch you later.